Hello everyone. Today we're going to talk about real numbers. So, first let's talk about what are we doing, why are we doing, and what's the point. So, the first thing is we're talking about real numbers and what do they consist of. That's important. They actually consist of very many parts. Then, how will you be learning? Well, you will listen to the lecture and you will participate in activities in Nearpod. And how will you know you learned it? Well, you will be able to determine whether they're natural, whole numbers, integers, rational or irrational numbers. So many parts to real numbers. You'll be able to compare and order real numbers and convert percents, square roots, and fractions into the decimal form, because that is very important if you do want to compare them. So this is what real numbers look like. This looks very, very, very complicated, but the reality of it is it's kind of like a little nesting doll. One thing is inside the other, inside the other, inside the other. And we're going to talk about what this is all about in a second. So first, let's talk about natural numbers. Natural numbers are what you would expect. They exist in nature, as in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Right? You can count forever. You can. Right? Do you know that we're not the only animals that can count? Actually, crows know natural numbers too. They can count up to 3. So natural numbers are the ones that you can point, right? You can say, okay, 1 cup, 2 cups, 3 cups, etc., right? However many. Okay, so that makes sense. Here's our lovely crow. Well, what about whole numbers? How's that different from natural numbers? And if they're different from natural numbers, are they unnatural? It's natural numbers and we add just one number to them, number 0. Now we start with 0. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the next question I want to ask you is this. Is 0 truly that unnatural? Go ahead and answer the activity in the Nearpod and tell me what you think. Well, personally, I don't think it's that unnatural because it was invented independently twice. Okay? It was invented by ancient Mesopotamians, and then it was also invented independently by Maya, and they had absolutely no contact with each other. So I would say that considering that it was invented twice by completely different people, I would say there is something very fundamental about 0. But we don't consider it a natural number because, once again, it doesn't exist in nature, and as far as we know, no other animal knows what 0 is, just us humans. Well, what about integers? What are those? Well, it's natural numbers and 0 and negative numbers. I know it sounds weird, but we don't actually have negative numbers in nature. I mean, like, I know it makes sense for us to, maybe I owe you 5 apples, and that means on my account there is minus 5 apples, right? But it doesn't exist in nature. It's like 5 apples that are missing. How do you explain that to an apple tree? You don't, right? So not particularly natural, right? But once again, they go all the way to the infinity in both directions, right? They go in the positive, like all the natural numbers do, and in the negative direction. Now, the biggest issue people have with integers is that people get confused when they see numbers like -4 and -3. because this is one case where your -4 is actually less than -3, okay? The more you go to the left, the smaller your number is. That means that -250 is less than 0 because it's negative. All right, so let's talk more about our integers. Once again, they increase from left to right. And if the number has a negative sign in front of it, the bigger number, the smaller it is, right? So between -10 and -7, -7 is the bigger number, right? It's how much you owe someone. Would you rather owe someone $10 or $7? Well, of course you want to owe less, right? When you owe less, that means the number is bigger, right? So what I want you to do right now is I want you to do a little activity in Nearpod and put the right sign between the numbers. Rational numbers. Let's talk about rational numbers. Well, we all know, some people are rational, some people are not so rational. That's not how it works in math, okay? Rational means ratio, and ratio means two things divided by each other. Rational numbers are denoted by this letter Q, right? Now, Q stands for quotient, which is why it's Q. So over here I have my integers, right? So the question is, well, where do rational numbers go? So you get rational numbers when you get to the integers, you divide one by the other, and you no longer get an integer. For example, you can divide 4 by 2 and then you'll get 2. That's an integer. But if you divide 1 by 2, you get 1/2. Okay? And it's not an integer anymore. It goes right between them. Awesome. So now I have a very interesting question for you to think about. And go ahead and answer that in Nearpod. How many rational numbers do you think there are between 0 and 1? So the answer is a little surprising. There are infinitely many. And there are actually infinitely many of infinitely many numbers. Why am I saying this? Because you know how you have 1/2 over here? You can absolutely change this to 3. Then you'll have 1/3. Then you have 1/4, 1/5, and so on. You see where I'm going with that? Yep. Infinitely many numbers. Pretty interesting. So let's talk some more about our rational numbers. Our rational numbers can be hard to compare because 1/2 and 1/3, I mean, we can tell that 1/3 is less than 1/2 because a third of a pizza is less than half of a pizza. We know that, right? You split the pizza between 3 people, you get less pizza than if you get between 2 people. But what about comparing things like 2/37 and 1/15? Like, what is that even, right? So the best way to do this is to actually convert these numbers into your decimal, into the decimal, okay? And we're converting them into the decimal very, very simply. We're dividing one number by the other, right? So we're gonna have 0, then we have 0 dot, and we have 5, right? We can go like that, the old-fashioned route. There is also another way of doing this, which most people don't really consider, and you probably really should. What you're looking at right now is Desmos, the scientific calculator. And what you can do is you can divide 1/2. And it immediately, of course, converts it into your decimal. In other words, ladies and gentlemen, yeah, you can do this properly if you really want to. Or you can take the easy route and use a calculator. So what happens if they don't end, right? You can actually have a number that never ends, right? For example, over here I have a decimal number that's 0.66666. This is 2/3. So here, let's do this. And there you go, 0.66666. In the calculator it says 6667, but it does in the end it does go on forever. The 6's go forever. It just rounds up the tail. So what about some more complicated numbers? However, how about 237? Well, I want you to look at the period over here, because the period over here is actually 3 digits, and it keeps repeating itself and repeating itself and repeating itself. This repeating of the period is a feature of our rational numbers. They all look like that. If you have a number, if you have a decimal number that has a repeating tail, we know it's the result of 2 numbers divided by each other. Okay? We know that it was the original fraction was a rational number. All right. So, let's look at irrational numbers. And when we talk about the word irrational, right, when you say irrational person, we know this is a person who is not rational. And that is exactly what it says. This line on the top says not you or irrational. Okay, so where do these guys go, and how can we possibly compare numbers with each other? Well, what about square root of 2? Where does that go? Well, let's see. I know that square root of 1 is 1. I know that square root of 4 is 2. So square root of 2 has to be somewhere in between them. That makes sense, right? What about square root of 5? Where does that go? Yep, it goes right there, closer to 2. Of course, this is the estimating route using your head. Once again, nothing stops you if you don't know the value to type in the square root of 2 into your calculator and see what it actually is. Because irrational numbers can be expressed as a decimal, but this decimal is not a repeating one. So remember how over here we had 2/37 and it was a repeating number? What about square root of 2? Well, here is square root of 2. And you can see that it has a long tail that goes on forever, and it never repeats the same sequence of numbers. It never ever will do that. And guess what? How many irrational numbers are between 0 and 1? Infinitely many. Yes, there are. Think about it.